Wiring of fire alarm systems. In this chapter, we will focus on the concepts and good practice of wiring. At the end, you will find a set of examples of drawing designs to understand how the wiring layout is, how the wiring should be routed, and put together complements such as the isometric and technical notes in the drawings. Let's review some concepts given in the previous sections. Here we show you the most commonly used circuit classes so far for fire alarm systems. At the top left, we have a Class A circuit. As we know, Class A circuits have a redundancy. This allows them to operate despite the existence of an open circuit. The detection loop and the notification loop can be wired in Class A. This class is most commonly used for systems looking for greater efficiency and greater maintainability. Obviously, the cost of making this wiring is a little higher, both in pipes and cable, but is the most effective one. Then, we have Class B on the right. This class does not have a redundancy, so they stop operating when the circuit is opened. Class B also allows us to make branches, as shown in the figure below, which allows us to make connections in this way, as you can see in the figure, which cannot be done in Class A. And finally, we want to introduce Class N. In the 2022 edition, they make a lot of emphasis in this class of wiring that also relates to cybersecurity, since now fire alarm systems allow communication with equipment using the network. Some features of this Class N are: they have a redundant path. This is only for network equipment that sends data, not for end devices. They cannot monitor or detect conditions that affect operability. It can be via Ethernet or wireless. Signal transport equipment, wherever routers and servers, must be leased for fire alarm service. This is very important. It is not like we can use just any router or server to achieve this kind of communication. Cabling, equipment, and network infrastructure must be clearly separated and identified as a human safety network. For more information, you can find it in the section 23.8.2.6.1 and 12.3.6. Using loop insulator modules. This is a common question that we have been asked a lot: how to place the insulator modules in the loops. Here are 3 correct ways to install insulator modules and how not to do it. It is important to note that insulator modules must be installed as close to the panel control unit or main panel as possible. In the figure above, on the left, you can see how the insulator modules are used for the different zones, which allows us to see if there is a failure in one zone and it does not affect the rest of the zones. On the right, we have a Type A wiring where the insulator module have been used by placing them one close to the panel and the others between the devices in the middle of the Type A loop. And the one at the bottom left, we show you a Type B wiring and how to correctly place the insulator module. And finally, on the right below, we show you the wrong way to place the insulator modules. The most important thing is to place the insulator near to the main panel. Separation rules for Type A wiring. This is very important because this marks as a rule how far the distance must be to reach a device from a connection box. As you can see in the figure on the left, which can be found in NFPA 72 chapter 12.3.8.1, the distance from the junction box to the device should not exceed 3 meters. What is shown is the pipe, but inside the pipe, as you can see, we have 4 strands of cable, as we have the outgoing cable as the return cable in the same pipe. This is allowed by the code, but we must comply with the rules. So, as you can see, we are limited in distance if we decide to wire this way. Now, on the right, since we only have a single device that's going to come out of the junction box, the distance to wire from the junction box to the device is unlimited. Let's now talk about the type of cables. In this case, we will focus on energy limitation systems, which are the most commonly used, which must be 18 caliber minimum. As you can see in the picture, we have the FPLP, which are those used for environmental spaces. This can be exposed. This cable can be exposed. They do not need to be inside a pipe. We also have the FPLR, which are the riser for vertical installations. And finally, the general purpose one, that are the FPL, that are the ones that you will generally use or are using right now. In the picture on the right, you can see how and what point each at this cable should be used. Below you can see we have the FPL type, which are used to wire all the devices, either notification or initiation. Then you have to go up. If we are in a building or a property where it has more than one floor, it is necessary to go up from a box to the one above. For this wiring between floors, it is necessary, which is known as riser, and is the one that is recommend or standard recommend to use, which is the FPLR. This cable has additional protection considering that its work is more important because they must support a higher temperature, considering that if there is any damage on the cable, it can affect an entire floor, unlike the FPL that if damaged can affect only a group of devices or one device. Both cables that we have seen so far require to be inside a pipe. And finally, we have the FPLFP, which is a cable with a stronger coating which allow it to install without using a pipeline. This can be pulled over the ceiling without pipeline without any problem. These are used when they are specified or when due to the nature of the infrastructure where it is not possible to pull a pipe. Obviously, this cable is more expensive than the previous two. For all wiring issues, wiring forms, wiring rules, you will not find information in the NFPA 72 code. These are electrical issues and we must find them in the NEC code. In the NEC code, they must refer to Article 760, which refers to everything that is wired. The 725, everything that is wireless communication, and Article 300, which refer to everything that are areas of risk or explosion or other risk. Now, let's review some pictures that are examples of good installation practice as well as wrong practices. In the first picture on the left, you can see a correct connection on a device with only two screws, where we will get in with the black cable as the red cable. Both wires are cut and enter the screw correctly. You can see that the jacket is not cut too short, so entering the device is the correct way to do it. The device on the right is a device end of line. As you can see, they have the end of line resistance, so they only have two cables, and this is the correct way to carry out the installation. Further to the right, we have devices in the middle of a loop with cables that come in as well as cables that come out. Now, it's strange because in this connection we see two red wires when it should be red and black. The main purpose of the picture was to demonstrate how to get in and exit from a device. Below we can see the incorrect ways. which, unlike the previous picture, in this one, even though it is a device that goes in the middle of the loop, they connect everything to the same screw. This is an incorrect practice to do. In the picture on the right, the cable looks like it was not cut, it was simply stripped and put in the screw. This should not be done. Let's now move on the connection in the boxes and on the main fire alarm panel. In the first picture on the left, we see a correct installation and connection and cable passage inside the fire alarm panel. You will be able to see that we use splicers for the installation. The code does not specify the use of splicers, but as an installer and experienced in the installation of fire alarm systems, we advise that you use this splicer for boxes, power supplies, or fire alarm panels where there will be several connections. In this way, you can avoid what happened in the picture below. The panel connections are just a mess. Everything is spliced and splicer are not used, and you will lose control. Also, in the picture above right, in the middle, we see a junction box of a fire alarm system that is properly marked. The box is red, and it has also been written that it is a box for fire alarm systems. Labels can also be used to achieve this same objective. The picture below, we see a box that is difficult to identify if we are standing below it, because the box is uncovered, and also you see a total mess of cables, which for future preventive and corrective maintenance actions, this will be a big issue.